We're going to assume that you paused it and that you tried these on your own. Remember that when you're multiplying with decimals, we can just line it up. Doesn't matter which way. We're going to line it up as if the decimals weren't there. So instead of putting 0.78 times 3.5, I'm going to forget about those decimals for a minute. I'm going to erase it, and I'm going to erase it. I'm just going to multiply. I'm going to multiply just like I would if they were normal numbers, and I'm going to do my long multiplication. Now, if you do lattice, that's fine. This method should still work, but I'm not as comfortable with lattice, so I'm going to do it this way. So if I multiply, 5 times 8 is going to give me 40, carry the 4. 5 times 7 is going to give me 35. I add those 4 in there, I've got 39. 5 times 0 is 0, plus 3 more, 3. Now I do the tens. So I did the ones times 0.78, and now I'm going to multiply the tens. 3 times 0.78. So I'm going to do 3 times 8, and that's going to give me 24. And I carry the 2 up here. I multiply 3 times 7, and I'm going to get 21. Add the 2 on, I get 23. And you'll notice I started that 4 underneath the 9. What really is happening there is I'm starting that 4 underneath the tens, underneath the 3, because that's what I'm multiplying with. I'm not multiplying with the 5 anymore. I'm not multiplying with the 1s. I'm multiplying with the tens place. And so that number is going to start underneath the tens place. Now I multiply 3 times 0 is 0, plus 2 more is going to give me 2. Add them together. 0 plus nothing is 0. 9 plus 4, carry the 1. And I'm going to get 2,730. Of course, I need to go back. I need to look at those decimals. There's no way that 0.78, 78 hundredths, times 3 and 5 tenths is 2,000 something. Not going to happen. So I'm going to put those decimal points back in. Now I'm simply going to count how many numbers are on the right side of the decimal points. In fact, I can draw a line here. I can say, well, here's the decimal points. How many numbers are on the right side? 3. 7, 8, and 5. 3 numbers. So my answer, there needs to be 3 numbers on the right side of the decimal point. If I put the decimal point here, there's only 2 numbers on the right side of the decimal point. That is going to be incorrect. So I need to put that decimal in between the 2 and the 7. Now there are 3 numbers on the right side of the decimal point. 0.78 times 3.5 is 2.73. The 0 you can leave on if you want. You don't need it, though. And I have to be very careful. I've got the right number. However, I'm multiplying, and these 2 numbers have different signs, positive and negative. If I go back to my rules, positive and negative, different signs, the answer should be negative. So it's negative 2 and 73 hundredths. We do the second one here. We got 2.05 times 5.7. I'm going to go a little bit faster here. Get out of here, Shaggy. We don't want the scared Shaggy. Okay. Going back then, so I've got a new problem here. I'm going to do 2.05 times 5.7. Again, I'm going to forget about those decimals for a little bit. I'm going to leave them there just because I don't want to erase them. But I'm going to multiply as if they're not there. 7 times 5, 35. And again, I'm going to go through this a little bit faster, but you should, it's the same process over again. I'm going to carry the 2. 5 times 2, 5 times 2 is 10. Add those together. And I'm going to get, if you want to put a 0 here, that's just fine. If you want to fill in that gap, if that makes you feel better, go for it. You can leave it blank like I did here because it's nothing. 0 is nothing. And you can certainly add it in if you want. Up to you. And I should get then my answer. Again, there's no way it's 11,685, so I have to count. How many numbers are on the right side of the decimal? 3. So my answer, 3. Now, I know that 2 times 5 is 10. So 2.05 times 5.7, 11.685. Sure, that seems reasonable. We should be able to say that, yes, that's a reasonable answer, or no, there's no way that's possible. 11.685 seems like a reasonable answer. Now I look, negative 2.05, negative 5.7. Same sign, positive. Not same sign, keep the sign the same. That's adding. So if we were adding these together, it'd be negative. But since we're multiplying, we have a different set of rules. Multiplying, they have the same sign as positive. Last one then, 4 times 0, anything times 0 is just 0. There is no positive or negative 0, it's just 0. And so we can leave that there.